All right, everyone. We're going to get started in a moment now. My name's Andy Blanc. I'm a distinguished architect at Red Hat.
And my name's Gerald Nunn. I am the technical marketing manager for GitOps at Red Hat.
And we're going to talk a lot about Argo CD and diffing. So we love to be able to get some feedback involvement. So raise of hands. How many in the room would say they know Argo CD? Raise your hand. Good. How many of you say that you really know Argo CD diffing? Okay, good. We're going to have a great talk then, because a lot of people have no idea about how Argo CD diffing works. And we're hoping that by the end of this presentation, you're going to not only have a better understanding of Argo CD diffing, but know how the different strategies work and how you might be able to leverage it in an environment of your own. So here's what we're going to talk about today. We're going to first provide an overview of what Argo CD diffing is. We'll talk about the different strategies of Argo CD diffing, everything from the legacy to some of the server-side implementations that are found within Argo CD. We'll then talk about how you enable the various different diffing strategies within Argo CD. And then finally, we'll then talk about the actual challenges. I mean, Gerald and I, we did a bit of investigations to prepare for this presentation, and we saw a lot of things. Some of it actually surprised us, and it's not in a good way either. And then finally, we'll have a demo that kind of showcases some of the strategies that we talked about. So first of all, what is Argo CD diffing? Well, it's really how changes are detected between what is desired which is going to be in your Git repository or rendered from a Helm chart or OCI manifest, and the live representation of it within your Argo CD, within your clusters, and what may or may not be out of sync. Now, like Kubernetes and my Facebook status, it's complicated, how it works. So one very important piece to know is Argo CD does not use the same emulated features of kubectl diffing. How many of you know or have ever used kubectl diff in the past? Honestly, before this talk, I never used it. I've been working with Kubernetes for almost a decade now. I've never used it. And I went like, huh, there's a feature there, which is nice. But we wanted to emphasize that Argo CD does not use that library. It goes ahead and uses its own internal library, as well as some libraries from the GitOps engine to perform the diffing action. And what does it really do? It goes ahead and removes some tracking information, but it also goes ahead and removes the common live data, the generation information, the timestamp, the stuff that you would figure would be out of sync and really don't need to worry about when it comes to diffing itself. So let's talk about the first one, which is going to be you're out of the box. If I just install Argo CD and I turn on an application sync, what do I get? It is the legacy version, or client side. It performs a three-way difference between the live state, the desired state, and if you use apply, it uses the last applied configuration annotation on the resource. Now what it does is it does emulate the kubectl diff, which is basically all client-side behavior. It does use the last applied configuration annotation to determine the desired detections between what's live and what's desired. And then, as I mentioned earlier, it is the default implementation within Argo CD. That's from the client side. We're going to switch over to the server side now. So server side basically performs a dry run apply and then compares the results to the desired state. Now, for handling ownership, it uses field managers to handle that. And it does try to emulate what the kubectl diff with the server-side apply flag utilizes. Now, very important to note is that the basic server-side diffing functionality within Argo is currently still in beta feature, which by turning it on, there is a slight performance impact. Now, we wanted to emphasize that if you really want to know more about Argo CD diffing, and on the server side, wait till the next talk. Leo Lutz and Peter Jiang has a great talk around server-side diffing in the next session that immediately follows us. And with a good demo on it too. Now, how would you want to go ahead and enable server-side diffing? There are two ways to do it. First of all is going ahead and making it globally configured or globally enabled. And then you do that very similar to any other global configuration in Argo CD. That goes ahead and modifies the Argo CD CM param CM config map. You basically set the controller diff server-side equals true. And that's how you do it in a global way. Now, you can also do it on a per application basis by setting the annotation that allows you to do it for an individual application. So you can control whether you want to apply the server-side feature either at a global level or at an individual application level. Now, there is one other type of diffing, and it's the structured merge option. This strategy is automatically applied when the server-side option is used and enabled. This is important because this is how it currently works as of this very moment. There is a draft pull request by the aforementioned Leo who is looking to move the traditional standard server-side implementation of diffing as the default. The difference between the server-side and the structured merge diff, because they both use server-side, is that this leverages the structured merge diff library in Kubernetes. So also uses field managers, very similar to the Argo CD server-side, as well as I mentioned earlier, they're looking to move it more towards this not being the default. So right now it's currently the default, but it's feature discontinued. There were some challenges that the community noticed with this implementation, which is why we're looking to move it from the default as it is today to no longer being the default using the traditional server-side diffing implementation. Gerald.
All right, so it's interesting when folks come to Argo, there tends to be a bit of a misconception around diffing. You think, hey, I do diffing all the time. I do diffing in Git, or I use Meld or different tools to do diffing. It's easy. It's like this one-color Rubik's Cube. Anybody can do it, right? The reality, though, unfortunately, is that in Kubernetes and in Argo CD, diffing is complicated. And it's complicated for a variety of different reasons. So we touched on these already. Some of these already. You've got multiple controllers in Kubernetes potentially affecting the same resource. And you have to track which changes are being done by which controllers or by which managers at any given point in time. And you have to be respectful when putting things in sync of those changes that those other managers are doing independently of Argo CD. So you have these field managers that you need to be aware of and to take into account. You also have schema considerations that come into play. So in Kubernetes, when you have your various resources, they have a structure to them, and there's a schema that defines that structure, and those schemas have various things that help you define what those do, kind of like SQL in some ways. Is it an integer or is it a string? In this case, you have things like, hey, can I omit this? Like the pause in deployment, you can omit that. You don't have to put that into every deployment, right? You have defaults that can be set for those in the schema as well. And finally, detecting deletions can be pretty tricky in this multi-controller world because do you want that field removed, or is it actually being managed by something else? Like, how do I figure that out from a Kubernetes or Argo CD perspective? So for all these reasons, you just can't use a simple two-way diff. And this, for me, at Red Hat comes up all the time. People say, why can't it just be a two-way diff? That's so easy. Well, this is why. Like Andrew's Facebook status is complicated. So one of the challenges you run into is the imperative versus declarative world, right? So kubectl apply. That is declarative in the sense that you've got your YAML file, you're saying this is what I want in terms of this resource definition, apply that to the cluster. But then you have imperative commands like edit and patch that can make point changes to the things that are running in the cluster, but they're done imperatively, right? You kind of go kubectl edit, you do your thing, and you're off to the races again. You're not defining, declaring the whole resource that you want to do.
So, Gerald, I've been in the Kubernetes space for a while, and we started out with the imperative world, and declarative really took over. What is the difference? How does diffing apply, whether you use something like kubectl edit or kubectl apply? What are the different ways that not only you can do it, but then how the different strategies perform against those differences? Right.
And we ran through a whole bunch of test cases here with edit and to see what the different behaviors were across the different diff algorithms. And we really saw a lot of interesting things, I thought, when we came through this. So the first one is that with the legacy diff, kubectl edit doesn't make any difference in terms of detecting a diff because it doesn't change the last applied configuration, right? And that is what is used to detect deletions. And if a field is not in last applied configurations, it's not considered as part of the diff. So that's why on the legacy diff, when you go kubectl edit on something, you don't see it. On the server side, it's actually quite interesting too, because in that case, it's more of a field manager issue. When you do kubectl edit, if you go look at the managed fields that get added to the resource, you will see the field manager is kubectl edit, right? So from a Kubernetes and Argo CD perspective, that is now a different field manager that is managing that resource. Interesting with kubectl edit on the legacy side, there is that -- save config you can add at the end. So you can go kubectl edit deployment basic app -- save config, and it will update the last applied configuration, and then that will be detected in the legacy diff. So that's a lot of the things that we saw in that. There's also things that controllers themselves insert, like the revision history limit on a deployment. And those have defaults. I think 10 is the default, right? And if you go and modify that, kubectl will not pick that up, because from its perspective, that's not part of your manifest, so it's just basically ignored, right?
It's lost in the ether.
Yeah, exactly.
So we talked more about the imperative versus declarative. Now, wait a second, we're ArgoCon, Git's involved. So let's say we wanted to make a change in Git. How did that, how does that play into the different diff strategies?
Right, and that was really quite interesting. We went through and tested various things, but generally speaking, it works as you would expect it to work. You make a change in your manifest, it applies to the cluster using, essentially kubectl apply under the hood. Everything's hunky-dory. But what becomes quite interesting is when you mix strategies. When you mix client side with server side, then you start running into these kind of edge cases where weird things can happen, and we can see that over here with all of the X's under the server side. So in this column here, we're doing a server-side diff, but we're doing a client-side apply. We don't have the server-side apply flag enabled in Argo CD application. And you can see when you remove things from the manifest, like removing a label or removing an annotation, it does not get detected by the server-side diff as a change, which is kind of, whoa, what's going on with that? And again, that is because of the field managers. And it's interesting in this case, and this is a good question for Leo and Peter in the next session, is that when you look at the field managers, they're both applying changes with Argo CD controller, but the apply is doing it with an operation called apply, and the client side is doing it with an operation called update. And I believe the server-side diff is looking for that apply operation, and that's why it's not detecting changes when you do a client-side apply.
Yep.
But Peter and Leo, good question for them on that one. And then the interesting thing too is if you look down towards the bottom with the revision history limit again, if you typo something, i.e. make it non-schema compliant, obviously the client side does not catch that at all. It's like, oh, that's fine, whatever, I'll just ignore it. On the server side though, it will fail. You'll get errors saying, hey, this is not a compliant schema, and you're all good to go. So that's really what we see across all the different algorithms, and kind of the weakness of trying to mix strategies, and it's a problem. And again, you pointed out Leo's making that change potentially. There's also a change for the server side as well to potentially, when you make server side the default for server side apply, to basically have a warning or a flag to notify people that when you use server side diff with client side apply that you might run into some edge cases or some problems, right?
So we talked more on how we make changes, either using kubectl, we then go ahead and used Git changes. The third one, because I'm kind of a power user of Kubernetes, what happens if I want to then introduce a mutation? A webhook, or it's going to be a controller, a policy manager, or like something like Kyverno. How many of you have either used Kyverno or have at least heard of Kyverno? So we went ahead and we did some testing with both Kyverno, but also a mutating admission policy, which is more of the in-cluster supported mutation capability within Kubernetes. And we saw some interesting differences. Talk through them, Gerald.
Yeah, this one was really quite interesting in a lot of ways. So you can do different things with a policy, right? So for example, you can add a label to it, you could change replicas, you can do all sorts of interesting things from it. And in terms of what gets detected, it's quite interesting how it works. So many times when you want to do a mutation, I think first we should start from a baseline expectation. You want to do a mutation, the idea is that you don't want to detect it as a diff. Right. The negative is actually the positive result that you're looking for, because otherwise your Argo applications are constantly at a diff and it's a pain to reconcile them. So it's more interesting to me the ones that do detect the diff. So the legacy, for example, does not particularly work well with server-side mutations as you would expect, because it's doing client-side diffing. It doesn't know anything about what's happening on the server. So if you start messing with things like replacing the image digest, change replicas from mutation, the legacy is going to detect all that. But similar to when you edit if you add something like a label or an annotation, that will not get detected for the same reasons that it wasn't detected before. It's not in the last applied configuration. So it just gets ignored on the legacy side, right? Server side, everything works fine. I've got a note here about the one on the Kyverno replacing the image digest. That was interesting. Kyverno fails with server-side apply.
Yep.
I don't know why. I looked into it a bit, but it wasn't obvious what the problem was.
The good news is we have a lot of contributors to the Kyverno project here at KubeCon, so there's a good chance we can run into them and find out ourselves.
Yeah, and then the other one that was quite interesting was, if you're familiar with enabling server-side diff, there's this thing called include mutation webhook. And I don't know about you, but you read the documentation, I was kind of scratching my head going, okay, what does this thing actually do? And so I spent more time than I probably should have figuring this out. And I also talked to Leo as well. And it's another good thing to ask him about as well for their opinion. But if you set that include mutation webhook to true, it's really kind of niche in terms of where it's useful. It's useful for when you're testing a change in the mutation. So let's say I want to roll out a new Kyverno policy. I kind of want to get an idea, what's the impact of this new policy across my apps? Like, what's it going to change, right? So if you enable this and then add the policy, then do a refresh of all of your apps, you will see that it will show you a diff for that mutation that Kyverno policy, that mutation webhook, the mutation emission policy is doing. As soon as you sync, that diff goes away, right? So it's only really useful for that kind of space between I made that change to how I'm doing a mutation to a refresh. That's really where you see that happening. But as soon as you sync again, it's all gone. So I think that pretty much covered all the things. We tested Kyverno, we tested a mutating emission policy, which I am very keen on as an aside. Yeah. And we also tested a mutating webhook as well, a classical mutating webhook. And basically got the same behavior across all of them in terms of what our expectations would be.
Yep. So there are certain situations where you may know that you want to manage differences effectively. And there are ways to potentially ignore when differences are detected, because you still want your applications to report green, even though there are maybe cases where, especially when we hit these use cases and these situations where diffing has some unexpected results, we still want our applications to still show green. So there are ways to configure Argo to say, hey, I detect a change, but I don't care. And you can either do that either globally or you can do it on a per application basis. Now it's important to know that you can also leverage the respect ignore differences option too. We'll go into that in a second. You can also look at how we ignore aggregated roles. So if you, it doesn't take into account how we handle aggregated roles. Then finally, Kubernetes has a couple known types that are a bit unique. There are ways to map Kubernetes known types to Argo CD properties so that the values get translated properly. Those are different ways to manage the diffs. Now, if you want to ignore differences, you can do that also, as I mentioned, at a global or application level. They can be specified either using JSON path RFC 6902 or JQ expressions. And as I mentioned earlier, the respect ignore differences annotation can be added to the application or at individual resource levels to basically ignore differences during the sync state. This is important because by default, the differences are only applied after the sync phase, and in reality, this feature is only good when you have a resource that's already in the cluster already and you want to just modify that and manage that resource appropriately. Here's an example for those of you who have not had a chance to play around with the various different ways to perform ignoring differences, whether it be a JSON patch flavor or a JQ expression. And then the final one at the bottom is basically how you can go ahead and set some system level ignoring of certain fields. So Gerald, want to just wrap everything up with some recommendations that we have?
So recommendations, basically be aware of situations where diff is not going to give you the expected results, right? And hopefully some of the things we talked about, the test cases that we ran through will give you some of the tools that you need to identify when those situations happen in your particular environments. The other big one for me is that never mix client-side, server-side strategies between diff and apply. If you're doing client-side apply, do client-side diff. If you're doing server-side apply, do server-side diff, right? It's a recipe for kind of wonky behavior if you try mixing the two modes across diff and apply. The mutable webhook, as I mentioned, I spent a lot of time trying to figure out what this thing does. It was interesting to finally understand it. For me, it's not something that you really need to have all the time, but it is very useful in niche cases. Like I said, you want to test a new policy, what to see the behaviors and the effects are. And as Andrew just mentioned, leverage the ignore differences as appropriate.
So good news, bad news. We only have 5 minutes.
Yeah, that's what.
So I'm thinking maybe we'll just go right to questions.
Yeah, let's do questions.
What we'll do is we'll post on LinkedIn and Twitter and all the social media the demonstration that kind of go in alignment with this, so that those of you in the audience, hopefully you can get a chance to look at that later, because we feel that answering your questions might be more valuable. So thank you very much for attending today. If you have any questions, we would love to answer them. Yes? In the same resource? So the question was, I don't know if everyone didn't hear it, what happens if you combine both JQ expressions and JSON path expressions, either at the same application level or in the same resource? And honestly, I've never tested that. I've usually always just picked one or the other. So that's a good follow-up. It does work? Okay, so it would not surprise me, because in most cases, the way the code usually works in Argo, it just checks to see if the property's there, and then it just goes ahead and determines if it needs to ignore it or not. So that doesn't surprise me. Anyone else? Yes?
When we have a secret, which by external secret, sometimes if you have a plain secret, like which contains a username, and then you have an external secret bringing the password. So the tracking ID keeps mutating to say that is matched by the external secret. And when the sync comes again, it says that it's matched by the secret, so it keeps changing and applying the diff.
So that's where you might be able to leverage that annotation, potentially the respect ignore differences annotation, because we're assuming that that resource is going to already be in the cluster already, potentially. That might be able to get around that. So you can look into maybe having that become a strategy for resolving that issue. Otherwise, what I'd recommend is either post an issue in Argo in the GitHub repository or on the Slack channel, and we can take a look at it in further detail.
The important thing with respect to ignore differences to remember is that you have to have the ignore differences defined. You can't just set respect to ignore differences equal true and off you go. You have to have one for external secrets. And if you look at the Argo CD documentation, if you haven't already, there is a section talking about the status section, for example, the external secrets that has some issues, but I think your case is probably more what Andrew's getting at.
Yeah. Yes?
I think we've just, in my company, kind of had an issue of trying to understand why you wouldn't have respect ignore differences true at all times. Like, I get the initial creation, maybe it doesn't matter, but why is it not defaulted to true?
It's a good question in terms of the default. There are cases, I think, with ignore differences where it's more transient in terms of, from a diff perspective, you want to ignore, but not necessarily from an apply perspective. So they're probably erring on the side of caution in that respect. I know, speaking for myself, I always have respect ignore differences set to true. Always, but I can understand from a project point of view, needing to take a more cautious approach.
As a maintainer on several projects, not the Argo project, but other projects, we like to take more of a conservative approach and then have individuals opt in to features versus have things be the default, because then you'll probably have someone say, why is this the default? I can only want to opt in. So that's usually the stance that we've seen in the open source community. Yes?
On the server-side apply and the server-side diff, is server-side diff going to be moved to a more GA aspect?
So that's what and what I mentioned earlier, Leo, who's going to be speaking next, he has a draft pull request currently submitted. So we're hoping that as that goes through the review process, it will become the default moving forward.
But you know what? That's a great question for Leo. Put some pressure on him when he comes and does his session next, and ask him that same question.
Yep. Yes?
Is there any preference about using ignore differences globally or on application level, or is it just case by case?
I like to make it, unless you have a use case where you need to define it globally, I like to keep it to be very specific to an application. That's just my preference, because in reality, you shouldn't need to ignore differences. However, try to limit its use, because if you're seeing the same type of behavior across the board, you might have a challenge with your actual resources you're managing in Argo.
So I'm going to respectively disagree with Andrew on that one. I generally prefer setting ignore differences global unless I've got something that I very specifically for that application, only that application needs to deal with. There's a couple of reasons why. First, if you have a multi-tenant environment, sending it globally benefits everybody, right? And the other one is that if you're trying to reduce complexity in that multi-tenant environment, i.e. not make your tenants have to deal with this stuff, it benefits them as well.
I guess it really depends on which configurations we're looking at.
Yeah, I mean, it depends too. Are you talking about cluster configuration versus applications? There can be some
Which one
variance.
would you say? So he's going application,
Oh, okay.
which I would, I think, more on my side, on my approach, to be application specific. But yeah, cluster configuration, like cert manager, fields, tecton, et cetera.
So you have somebody else that's wrong. I'm just joking.
But yeah, so there, as we just pointed out, this is a great use cases of why you would want to do them differently for the different use cases and personas you have. Anyone else?
Got one more. Do you want me to use the mic again?
It's up to
Sure,
you.
go ahead.
Yeah, I think one thing that we've also struggled with is that there's the option, for setting the JSON path or the pointers, and you can ignore differences from any managed field manager, right? Or you can set managed field managers ignored on like a group kind level. I feel like one thing that I've struggled with is not being able to ignore differences from something like the Gateway API making changes, and not ignore the entire thing that it says that it owns on that resource. Would you recommend that you still try and lean towards defining a managed field manager so that it can kind of take control of what it knows it's going to be updating? Or would you?
So I'm not very familiar with the Gateway API, I'll be upfront with you. We're both OpenShift people, so we do a lot of routes. But I do stuff with the field managers, and I'm usually selecting the field manager plus a very specific item, like a path, a JSON path that I want that to ignore if that field manager is the one that's controlling it or setting it. But I haven't had a need for more granularity over and above that.
I think maybe that's the thing that I'm confused about. Do those work together?
Yeah, they work together.
Okay.
Yeah.
How would you then test these things before committing as changes to your ignore differences blocks?
So it depends, again, on what you're trying to test. So something like the Gateway API, if it's something that's going to impact things globally, you may want to test it in a lab environment.
That's exactly what I was going to suggest too, is doing a lot of the changes, especially when you're experimenting. Do that all in a lab environment. Hold off on getting to a higher level environment so you had a chance to really perfect your configurations. You'll know how the applications work and then some. And if you don't have a lab environment, seeing if you can go ahead and at least limiting it to a specific application that may only be in a specific namespace, so it's not a global change until you feel confident that you might want to roll something out globally.
Yeah. And I think we're at our time here,
We're
so
out of
we
time.
should probably.
Thank you very much, everyone.
Thank you.